Hello everyone and welcome to the first discussion of Conic section, circle. All right. Forgive me if my mic is very low. All right, and as much as possible, I try to make my mic closer to my mouth so that you will hear what I'm trying to explain. So I think you can just increase the volume. All right. Forgive me because I try to adjust. But anyway, all right. So this is the first discussion. We're going to talk about circle. So let's have a recall before, right? In the introduction of conic section, how do we generally identify whether the given general form of a conic section is a circle, ellipse, parabola, hyperbola, or not, right? So the technique is you will know that the given general form of a conic section is a circle if the coefficients of x squared and y squared should be the same in terms of number and signs. Just like this, for instance, look at the x squared and y squared. You see, the coefficient of x squared and y squared is 1. They're both the same. And not only numerically speaking, they're the same, but in terms of signs. The signs, in fact, are the same. Another example, we have 2x squared plus 2y squared. Oh, same number for x squared and y squared, and both of them are positive. And lastly, we have negative 5x squared minus 5y squared. See, same number, the same sign. So here we can generally identify that this is a circle. But remember, again, generally identify. So it's a general identification. Remember last time in the video, I think that's like uh, the general identification, not the practice video, okay? It's about the general identification something. All right. I explained there that it's a general identification, so that means it's not an exact identification. So meaning there's a chance that this circle right here, the one I showed to you, it may be a circle or not. And how would you know if it's exactly a circle or not? We will learn that in this topic. All right. So this is actually it's been segmented by parts. All right. So the first part we're going to talk about, which is the first segment, is the introduction to circle. All right. All right. And then other stuff that we're going to learn about it. So let's proceed. So let's have an introduction. What the circle looks like. It's look like this, right? You see this drawing right here? You know, this drawing right here? That's a circle already. The circle has two main parts. You see the blue dot? That's the center. And you see the chord, or maybe not the chord. Let's just say a line segment, rather, a line segment where it shows the distance between an endpoint or the corner of a circle and and a center. You know, if it shows a line between the corner or the endpoint, rather, of the circle and a center, that is what you call the radius. Okay, that is radius. All right. So what if, let's just say, I have a chord, right? Maybe, yeah, chord. But wait, let me write it here, okay? Let me draw another circle. So what if I have a circle? This is the center, all right? I draw a chord that passes through the center, okay? Passes through the center. Like the line, it's so straight, okay? It's straight. It's not like what do you call it? So it's not you know, basically you get the idea what is straight. You know, it's not bendable or it's not a curve shape. It's straight line, a straight line passing through the center. All right, and the endpoints are from the corners here. Okay, here these are the endpoints. Now, if you see these a chord that passes through the center, that is not what you call radius. Rather, this is what you call diameter. Remember this, okay? This is diameter, okay? Diameter. Okay, diameter is basically twice the radius, okay? Twice the radius, all right? Because if you're going to cut this into half, like cutting it from, halfway through the center, all right? You will have two radii, right? Radii is just a plural form of radius. Radii, right? So now you get some background information about the circle. But now we're going to relate it with conic section. All right. So let's have a definition. What is circle. All right. So according here, basically it's endpoints like the corners here, the corners of the circle or the corners of this shape, they are equidistant to a fixed point. All right. What does it mean? All right. What I mean by equidistant to a fixed point, it's like this. All right. We have a circle here. All right. Oh no, no, that's not a circle. That's an oblong shape. All right. Yeah, right here, right here. All right. Let's just say we have the center. This is the center, the red dot. Okay. Or no, no, no. Let's make it blue. All right. Let's make it blue. Okay. Now, you see this curve here, the white part. All right. Take a look at them closely. Okay. Let's just say I'm going to make a line. It's a radius. Okay. So I have to start from here at this corner, going to this center. All right. Now, assume that the distance between from this point and that center is, let's just say 2 inches, right? 2 inches, right? Let's just assume, right? Now, what if I will draw another radius in that circle? Like, for example, here, right here, okay? A straight line, uh, it shows a distance between the center, which is this one, and this endpoint. All right. Okay. So what's the measurement? What's the measurement of the radius here? It's still 2 units, right? 2 units. Okay. Or how about here? All right. Here. What's the measurement from the center up to this point? It's still 2 units. So anywhere, like any endpoint or the corner of the circle, if you draw radius to it, all right, what would be the length of the radius there? That would be the same thing as the measurement of the other radius or radii. All right. So initially, we drew a radius here whose measurement is 2 units. So that means the other radii or in singular form radius, it's also 2 units. All right. Hence, they are equidistant to a fixed point. All endpoints, okay, meaning all corners, okay, all corners of the actually geometrically speaking, it's not a corner. Okay, geometrically speaking, it should not be corner as the word to describe this. All right, but basically at the what do you call this one? We can just say that instead of corner, or let's just say at the curve, okay, at the particular point of the curve, much better, okay. But yeah, you get the point. Uh my point is that like at any point on the curve, okay, any point, what is the measurement of the radius? That will be the same thing to the other radii or radius form. All right. If we have 2 units here, then that means we have 2 units as well here and 2 units as well at any points of the curve or endpoint rather. All right. So here we have the general formula of the circle. So the general form of the circle is ax squared plus ay squared plus bx plus cy plus d is equal to 0. All right. If you would notice, it's ax squared plus ay squared. All right. Meaning the coefficients of x squared and y squared are the same. Right. They are the same. All right. What would be the number for x squared? The sign for x squared, that will be the same thing for the y squared. All right. So if I have, for example, if I have 2 here as for the x squared, then I will have 2 for the y squared as well. All right. So bottom line, the coefficients of x squared and y squared are the same. That's why it's called ax squared plus ay squared. Okay. Then we have the standard formula. Okay. Now we have another formula to know, which is standard formula. The standard formula, this one is so useful that it will actually tell you what would the circle would look like. All right. In fact, this one is actually derived from the distance formula. All right. It's derived from the distance formula. All right. What's the distance formula? When we say distance formula, basically uh, suppose we have two given points. For example, from this point up to this point, all right? This is point one, this is point two. You want to know the distance between them, right? You want to know the distance between them, point 1 and point 2, all right? So here, assume that the coordinates of the point 1 are x1, y sub 1, and x sub 2, y sub 2, all right? So in here, we can get the distance between them via distance formula, which is d, which is the distance, is equal to the square root of x sub 1 minus x sub 2 minus x sub 1 squared plus y sub 1 minus y sub 2 minus y sub 1 squared. This is the distance formula. All right? It will tell you the distance between these 2 points. Now, why is it what goes on? Why did I said that uh it's a standard form of a circle, which is this one. It's derived from the distance formula because their formula is actually similar. All right, they're similar. In fact, it's geometrically related to this to this uh to this part. All right. So here's the thing. All right. So let's just say that okay, you are drawing a circle. All right, this one. This is the center. Okay, the center. Let the coordinates of the center be h and k. All right, h and k. Then we have a radius here. Okay, from here to here. Okay, this one. And here, okay, let's just say this is point P, and it has a given coordinates, which is x and y. All right, x and y. Suppose you want to know the distance between the center and then the point P. All right, it's like, oh, okay, I want to know the measurement of the of the distance between the two of them, because if I get the distance between the two of them, I can get the measurement of radius. Okay. It's like, okay, we have the center, we have the point here, and then you want to know the measurement of radius. And remember, the measurement of radius is just basically the distance between the center and to a given endpoint. All right. Which is this one, the point P. So here you will apply distance formula. So you have r as your d is equal to the square root of, we have x sub 2. Let's just use x sub 2 as x because x sub 2 is usually on the right side of the curve, or the right side of the yeah, basically what's on the right, that's actually your x sub 2 usually. So here, let's just say we have r is equal to square root of x minus x sub 1, which is on the left, h squared, plus y sub 2, which is y, minus y sub 1, which is k squared. All right. Then here's the thing. We square them both sides. We will have r squared is equal to the square of x minus h plus the square of y minus k. All right. Hence the formula. All right. The standard formula. Okay. So, all right. It is in fact derived from the distance formula. All right. So, okay. Let's go back to what I said. Okay, this is a new formula. So what's the use of it? I mentioned that this is very useful because it tells you what would the circle would look like graphically speaking. All right. So first, h and k are the coordinates of the center. So the hk will tell you where is the circle centered. Where is circle is located by knowing its center on a given plane or on a given Cartesian plane. Then r is the length of the radius. Okay? So if you know the coordinates of your center, h and k, and the length of the radius, there you will know what will the circle will look like, right? Especially uh if you're going to know its position, like where it's located, like where is the center located? Is it exactly at the origin? Is it on the positive x-axis, so on and so forth? All right. Now, okay, we had the introduction of it. Now, what we're going to do is we're going to focus on, we're going to continue discussing this one. But here, not only we're going to discuss the introduction, which we did, by the way. We are already done introducing the standard form, the this the shape, this one. But the next thing we're going to discuss for this in this video is general to standard form conversion. All right. The next video, we're going to talk about standard form to general form conversion. Now, why do we need to do this? Like, right, we have general form, right? Ax squared plus ay squared plus bx plus cy plus d is equal to 0. Now, imagine you're going to convert it into this, right? From ax squared, ay squared, yada yada, into uh, the square of x minus h plus the square of y minus k is equal to r squared. This is our goal. We convert this to this. All right. What's the reason? The reason is not only that we're going to learn how to do it, but this is useful for graphing. Again, what's the use of standard form? For us to know what would the circle would look like graphically speaking. All right? If we know the center and the radius, I mean the coordinates of the center and its length of radius, there we will know what would the circle would look like, especially where it is located. All right? So what are the steps? We have the case one, okay? Like what if your circle would look like this? Ax squared plus ay squared plus b. Basically, second degree terms only. Second degree terms and constant term exist only. Just like this. X squared plus y squared, then a number. X squared, y squared, and then a number. X squared, y squared, and then a number. That's it. There's no x, there's no y, only x squared, y squared, and a number. So, what are you going to do if you encounter this case? Okay, how are you going to solve, or how would you convert this general form into standard form? So there are two sub cases. Okay, so case 1.1, the coefficients of x squared and y squared are 1. Okay, meaning it just look like this: x squared plus y squared. That's it. There's no visible number here, right? No, there's no visible number, right? No visible number, just x squared and y squared. If it's if it's not visible, that means the coefficients of x squared and y squared are 1, all right? Or is 1, basically. But yeah, you get the idea. It looks like it's x squared and y squared only. So what am I going to do? If you have like this, like x squared plus y squared minus, for instance, I just say 3, all right? There's no visible number here. So what are you going to do? All right? So what you're going to do here is that x squared and y squared should be on one side of the equation and the constant term should be on the other side. For example, we have x squared plus y squared minus 4. All right? Let me rewrite that. X squared plus y squared minus 4 is equal to 0. Now, there's no visible number for x squared and y squared, right? It just exists as x squared and y squared. Why? There's no visible number. So what am I going to do? Just group the x squared and y squared together and put the number outside or the constant term outside. So that means I will have x squared plus y squared, then transpose negative 4 to the right, I will have positive 4. And that's the answer. That's it. All right. Another example. Let me make another one. Let's just say I have x squared plus y squared minus, let's just say 20 is equal to 0. Same thing. If you're going to observe, there's no visible numbers for x squared and y squared, or visible coefficient, basically. So we're going to group this one, then put 20 on the right. Hence, you have x squared plus y squared is equal to 20. That's it. Right? There we go. That's how you do it. Now, what if it has a number? Visibly speaking, it has a number. Like, for example, 2x squared plus 2y squared minus 1 is equal to 0. Or what are you going to do if you have this? That leads us to the case 1.2. All right? The coefficients of x squared and y squared are not 1. So what am I going to do? First step, you divide the equation by the coefficient of x squared and y squared. Okay? So let's use this one as an example. All right? We actually have this one. Right? We have this one, right? 3x squared plus 3y squared minus 1. All right? So if you're going to observe, it has a visible number or visible coefficient. All right? So first step, you divide the equation by the coefficient of x squared and y squared. In other words, you're going to divide the equation by the numbers of x squared, by the coefficients of x squared and y squared. So since both of them have 3, so we will, let me rewrite this one. So since both of them have 3, so that means we will divide both sides by 3. Okay? So 3x squared divided by 3, it's x squared, plus 3y squared divided by 3, y squared, negative 1 divided by 3. So 1 is not divisible by 3, so we can leave it as a fraction. So negative 1 all over 3. Then on the right side, 0 divided by 3 is just 0. Okay. Now what's next? Now, after you divide, here's the second step. The second step is x squared and y squared should be on one side of the equation, and then the constant term should be on the other side. All right. So that means just like what we did here, similarly speaking, we're going to group x squared and plus y squared, okay, in one side. Then the constant term, we're going to put it on the right. Hence, you have x squared plus y squared is equal to 1/3. All right. Hence, that is your answer. All right. That is your answer. Okay. Let's try another one. Right. Earlier, I put 2x squared plus 2y squared. Right. Now, let me just put different number. Let's just say minus 4 as our constant term. Okay. Now, if you would observe, there is a visible number. It's not x squared and y squared anymore. It's 2x squared plus 2y squared. So, what are we going to do? First step, we will divide the equation by what? By the number or the coefficient of x squared and y squared. So since both of them have 2, so we will divide both sides by 2. 2x squared divided by 2, x squared. Plus 2y squared divided by 2, y squared. Negative 4 divided by 2, negative 2. 0 divided by 2, 0. Then, the last step, group x squared and y squared alone in one side, while the constant term shall be put on the other side. So I will leave x squared plus y squared here alone and put negative 2 on the right side. So the answer here would be x squared plus y squared is equal to 2. And that is your final answer. Okay, so that's it. All right. So in here, at least you get the idea on what you're going to do. Right? Now here, if you see x squared, y squared, and then a given constant number, that is what you're going to do here. Okay? These things, alright, the one I showed to you, are the steps on converting a standard form to general form to standard form, where you have x squared, y squared, and a constant term. But what if, okay, we have x squared, y squared, and constant term, but there is x, y, or both of them. Like, for example, I have x squared plus y squared minus 2x plus y, then a number. Oh, what am I going to do when it comes to this case? So here we will have case 2. All right? Case 2. All right? So here, case 2, we have second degree terms, constant term, and at least one first degree term exists. Okay? So if it look like this, okay, even if like for example, what do you call this one? Even if for example there's no y, but there's x, like let me write it here. Let's just say x squared plus y squared minus 2x plus 1, like that. Even if there's no y here, this is still part of the second case, okay? At least, again, at least first degree term exists. At least one first degree term exists. Meaning, it could be x, it could be y, or there exists both of them, x and y, all right? But yeah, let's go back. What are we going to do if there's X, Y, or both of them? So these are the steps, all right? So likewise similarly for the case 1, there are two subcases, 1.1 and 1.2, all right? Here, Similarly, it has its own subcases, 2.1 and 2.2. So for 2.1, okay, like the coefficients of x squared and y squared are 1. Just like this, for example, x squared plus y squared plus 2x minus 4y minus 4. All right, basically, there's no visible number. All right, there's no visible number for x squared and y squared. So what are you going to do? So first step, all terms that have variable will be grouped on one side of the equation while the constant term will be on the other side. All right? So I think it's better if we're going to apply it with the example. All right? So for example, like this, x squared plus y squared plus 2x minus 4y minus 4. All right? There's no visible number here for x squared and y squared. So we're going to apply case 2.1. The coefficients of x squared and y squared are 1. So what are the steps? First step is what? First step is all terms that have variable will be grouped on one side of the equation, while the constant term will be on the other side. So all variables would be grouped on one side. Let me rewrite it here. Let's just rewrite the given x squared plus y squared plus 2x minus 4y minus 4 is equal to 0. Okay. Again, first step, all terms that have variable will be grouped on one side. So meaning the one that has letters will be just stay on one side. So x squared, y squared, 2x, and negative 4y. Both of them have letters, so we will just stay it right there. Okay, just stay there. Then the constant term, negative 4, will be put on the right side or transposed. Hence, we will have x squared plus y squared plus 2x minus 4y is equal to 4. Okay, that's it. Now, second step. Second step, on the side where all terms that have variable, you will group all x and y's. Okay, basically on this side, okay, on this side where all terms have variables, you're going to group them according to their letters. Group all the x's, group all the y's. So here we have x squared and 2x. We will group them together. We will have x squared plus 2x. Next, we have y squared and negative 4y. We're going to group them together. So we will have plus y squared minus 4y is equal to 4. That's it. So we're done with the second step. Now for the third step, we will do completing of square for x and y. Do completing of square x and y. What do you mean by uh completing of square? Basically, you're going to transform these two, okay, these two, x squared and y squared, into PST, perfect square trinomial, all right? So, how are we going to convert it? Or how are we going to convert it into a perfect square trinomial, right? From this, okay, to PST, okay? And likewise from this to PST. But the question here is how? How are we going to do that? Okay? So first and foremost, make sure that you have two given terms. Or you have two given terms. One is a second degree term in which it looks like this. Okay? It could be x squared, y squared, any variable. Okay, but as long as it has a second degree term. And it has first degree term. Okay? And that first degree term has a given coefficient, of course, all right? In which i- the coefficient should be a real number, right? Basically, if you encounter x squared plus bx, okay, where the coefficient of x squared is just 1, meaning there's no visible number for x squared, okay? Then for the term on the right, which is bx, the b could be any number, it could be 1, 2, right, negative 1, but not 0, okay? But not 0, okay? So if you have a form that look like this, then you can do completing of square. How will you do completing of square? Here's what you're going to do, okay? First, you get the coefficient of your x, the number beside your x, not x squared, x, okay? So it's b. Then you divide it by 2. Then you square them together. That's it. Okay? All right? So let's try to apply it to these two. X squared plus 2x, y squared minus 4y. Let's try here. Again, the first step, okay, make sure that the form, it has second degree term, or basically a term that is in squared, and the coefficient of the squared should be not visible, meaning there's no number beside the squared. So here we have x squared, so okay. All right, next, it has a first degree term, which is this one, 2x. All right, first degree term basically is just an x, nothing more, nothing less. Okay, so here, what are we going to do? So what we're going to do here is simple. First, we get the coefficient of x, which is this one, 2. All right, what we're going to do is we will divide that 2 by 2, then square them. 2 divided by 2 is 1. And square it, you will have 1. Okay, this is the result. Okay, now let's leave it that way. Let's leave it that way. Okay, now let's proceed to y squared minus 4y. All right, y squared minus 4y. Okay, so here, if you're going to observe, it has a second degree term, or in this case, a squared term, and we have a first degree term, or basically just a letter that doesn't have an exponent other than 1. All right. So point being, we have a second degree term, which is a squared term. And here we have a first degree term, which is just y. That's it. So here we can apply completing of square. Okay, what to do? First, you get the coefficient of your y, okay, or the first degree term, which is negative 4. All right. Next step, you divide negative 4 by 2. So you have negative 2. Then after that, you square the result, 4. That's it. So what are we going to do now? Okay, we got the result. So what does it mean? So that means, okay, we have 1 and 4 here. That means the result would be you will have positive and negative 1 beside 2x, and positive negative 4 beside 4y. So here's the result. Okay, it would look like this. Let me just erase this. Okay, okay, it would look like this. Okay, so we will have x squared. Wait, no, no, no. All right, let me just draw here. Okay, so yeah. Wait, no, 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 no. Here. Right, right. So here we will have x squared plus 2x. Then again, beside 2x, you will have positive negative 1. So you will have plus 1 minus 1. Okay? Let's proceed. Plus y squared minus 4y. Then again, right, we have positive. We have 4 as the result, right? So we will have plus 4 minus 4. Right? That is equal to 4. That's it. All right? Then what are we going to do? What we're going to do is the negative numbers, negative 1 and negative 4, we're going to put them on the right side. So as a result, we will have x squared plus 2x plus 1 plus y squared. Uh, wait, wait, wait. I think it's better if I'm going to put it with red pen, all right? Plus 1, then plus y squared minus 4y, then for the green, plus 4, then is equal to 4. Then since you transpose negative 1 and negative 4 to the right, so they will become positive. So positive 1 and plus 4. All right, plus 4. That's it. Okay. So what now? You simplify. All right. That's the last step. You simplify both sides of the equation. All right, let's start first with the easy one on the right. Here, all you need to do is just add them. You're done. Okay, 4 plus 1 plus 4 is simply 9. Now here, in this case here x squared plus 2x plus 1. Here, we can simplify by its what? Squared binomial. Because remember, look, you see this x squared plus 2x plus 1 and y squared minus 4y plus 4. These two now are in PST. Okay, they are now in PST, perfect square trinomial. And a perfect square trinomial can be converted into a squared binomial. For example, if I have x squared plus 2xy plus y squared, okay, this is a perfect square trinomial. I can convert it into x minus y squared. Okay? It's a squared binomial. Okay? When we say squared binomial, basically it's a polynomial that you have two terms and they are squared. Okay, they are squared. Just like x minus one, x minus y, then squared. So with that, we can do the same thing for the x squared plus 2x plus 1 and for the y squared minus 4y plus 4. We can do the same thing for the both of them. The question is how? How are we going to make it into squared binomial? It's simple. And what would that be? All right. So here's the thing, right? The technique here is first you put the parenthesis that's in squared. Okay. So here we will have like a square parenthesis for x, and that's the same thing for the y, square parenthesis. Okay. That's the first step for the technique. Then for the second step, okay, look at the variables used here. Okay. So here, on the x squared plus 2x plus 1, the variable used here is x. So you're going to put x here. Then here, for the y squared minus 4y plus 4, they use y. So put y here. Okay. For the y terms. Okay. Then after that, what's next? Now let's go back here. Okay. Let's go back here. Okay. Here. All right. Remember that for us to get the perfect square trinomial, we do completing the square. Remember the x squared plus 2x? Remember this one. All right. So what did we do? We divide the coefficient of x by 2. All right. 2 divided by 2, 1. Right. So here's what we're going to do. What's the result inside of that squared or inside of that parenthesis? That is what you're going to put it here. All right. So right, we have 1. 2 divided by 2 is 1, right? So what you're going to put here is plus 1. Okay? That's a technique. And that's it. Okay? Plus 1. Why is it plus 1? Because it's positive. All right? Now, likewise, that's what we're going to do for the y. All right? So remember, we go back here. Okay? We go back here. Okay? Here, this one. Okay? Remember that we divide negative 4 by 2, in which it resulted to negative 2. So now what are we going to do? What's inside the parenthesis? You are going to put it here. So since we have negative 2, so that means we have y minus 2. And that is the standard form. All right? This is the standard form for this given problem. That's it. Okay, that's it. Now let's have one more example. All right. Let's just say we have this one. X squared plus 2y squared plus 8x minus 8y minus 16. Oh no. Since like the numbers for x squared and y squared are visible, right? Meaning it has numbers. All right. It has two. Compare that before here. It's just x squared and y squared. Here it has a number. So what are we going to do? We will follow case 2.2. Okay, case 2.2. The coefficients of x squared and y squared are not 1. Okay, so basically it could be like, for example, 3x squared plus 3y squared. Okay, or it could be 2x squared plus 2y squared, just like earlier. Or it could be also negative x squared minus y squared. Okay? It could be like this. Because here, the coefficient of x squared and y squared are not 1, but rather it's negative 1. Okay? So, what are we going to do? Okay, let me rewrite the problem here again. We have again 2x squared plus 2y squared plus 8x minus ay minus 16. Okay, first step, divide the equation by the coefficient of x squared and y squared. Okay, since the coefficient of x squared and y squared is 2, so we're going to divide both sides by 2. Okay, So here's the result. 2x squared divided by 2 is x squared, plus 2y squared divided by 2 is y squared. 8x divided by 2 is 4x. Negative 8y divided by 2 is negative 4y. Negative 16 divided by 2 is negative 8. Then on the right side, 0 divided by 2 is just 0. All right? So, what's next? Now, we proceed to the next step. So the next step is just the first step on the case 2.1, which is all terms that have variable will be grouped on one side of the equation while the constant term will be on the other side. So basically, the one that has letters or variables will be grouped on one side while the constant term will be put on the right side. So these four, x squared, y squared, 4x, and negative 4y will be put on that place, while the constant term, negative 8, shall be put on the right. So we will have x squared plus y squared plus 4x minus 4y is equal to 8. Okay, then the next step is on the side where all terms are variable, you will group all x and y's. All right, so it's just like what we did in 2.1, So here, we'll group all the x and y's in the sides. All right, so let's group first the x's. So x squared plus 4x, then the y's. So plus y squared minus 4y is equal to 8. That's it. Then the next step is, all right, if you remember, you will do completing the square, all right? You will do completing of square, okay? So how to do that? Okay, make sure again that it looks like this. Okay, x squared plus bx. Okay, it always look like this. Okay, look like this. Okay, like this. Okay, a squared term and a term that has a first degree term. Basically, it's only a variable, but it's not in squared. It's a variable. Okay, that's it. Okay, again, it should look like that. A squared term that there is no visible number beside it, and a first degree term that has a variable in which the number beside that x should not be 0. Okay, so let's just say we have this one. All right, let's start first with x squared plus 4x before we proceed to the y squared minus 4y. All right, so what to do? Just like the same thing we did before, we get the coefficient of x, which is 4. So what are we going to do? We will divide 4 by 2, then we square it. 4 divided by 2, 2. Square it, 4. All right? Next, we will do the same thing for the y. So for the y, okay, y squared minus 4y, okay, it's similar as this form, so we will use completing the square. Okay, so first, we get the number beside the y, all right, or the coefficient of y. So it's negative 4. So negative 4 divided by 2, right, then we will square it. So negative 4 divided by 2 is negative 2. Then square it, you have 4. All right. So what's the result? Okay. So the result here is that, okay, since you have 4 as the result of completing the square of x squared plus 4x, that means you will have plus 4 minus 4. Okay, plus 4 minus 4. So let me write it here. X squared plus, no, no, no. X squared plus 4x plus 4 wait, sorry. Let me write it in green color. By x squared plus 4x plus 4 minus 4. There we go. All right. And that's the same thing goes on for the y. Okay. Since we have the result of 4, we will put positive negative 4. Okay. Or plus 4 minus 4. So we will have plus y squared minus 4y. Then plus 4 minus 4. Okay. Plus 4 minus 4. Then is equal to 8. Okay? What's the next step then? The next step here is the negative constant numbers, the negative 4 and negative 4 here. You're going to transpose it on the right side, right? On the right side. So result being we will have x squared plus 4x Then here we will have plus 4. I'm going to put, let's say, color here. So plus 4, then plus y squared minus 4y, then plus 4, I guess the red one, okay, is equal to 8. Then, right, we transpose negative 4, the green one to the right. So here you will have positive 4, all right? Then here we transpose negative 4 as well, this one to the right. So we will have plus 4, all right? Then the last step, we simplify both sides of the equation, all right? So we have this, right? X squared plus 4x plus 4 and y squared minus 4y plus 4 and 8 plus 4 plus 4. Let's start first on the right side. Right side is easy. Okay, just add them. 8 plus 4, 12 plus 4, 16. So you have 16. Okay, now these expressions, they are in PST. Okay, this is already in perfect square trinomial because perfect square trinomial already has a what? A constant term that is positive. Okay? So remember that a perfect square trinomial can be converted into a squared binomial. The question is how. Okay? So here's how. All right? The technique is first you put square parentheses for the two of them. So for this, okay, we're going to put square parentheses. Likewise for this one, I square parentheses. Okay? Next, what we're going to do is we're going to put the variable here, okay, here within the parentheses. And that variable is the one that they used here, all right? So here, in this expression, they use x as a variable. So we will put x. And here, on the other hand, it used y, so we will put y. And that's it, all right? Then what's next? Then we will go back here, okay? We will go back here. Okay. So remember that for us to complete the square, right, we divide the coefficient of x and the y by 2, then we squared it, right? So let's focus on them specifically. So here, we get 4, right? And we divide it by 2, in which it results to 2. So what is the result inside of that parenthesis? You're going to put it here, all right? So since we have positive 2, so we will have plus 2, right? Then for the y, okay, the same thing. Just look inside the parentheses here, parentheses squared. So right, we divide negative 4 by 2. The answer is negative 2. So that is what you're going to put it here. So you have minus 2. That's it. All right. Then here, oh, I forgot plus. Then here is your final answer. This is the standard form of uh 2x squared plus 2y squared plus 8x minus 8y minus 16. That's it, right? There we go. Now, here's the thing. Let's have a practice tomorrow about this, like converting general to standard, all right? Now, if you would notice, in my previous example, we have x and y, all right? Just like here, we have x and y, right? We have x and y. But what if only one of them is given? You know, only one of them is given. Just like this, for example. Ah, wait, no. You know what? Let me just fix the practice problem here. But yeah, point being, what if, for example, I have x squared plus y squared minus 10x plus 1, like that, right? There's no y, there's no y, just x. Okay? And vice versa. Like, what if instead of x, all right, only y exists, there's no x, all right? What are we going to do? So, in the next video, we're going to talk about that. There would be a practice and continuation for this. All right? So, I hope you guys learned something in this video. All right? And that will be all, guys. See you.